Hi, this is Team 22005 for the Tonee Lift Walker. To start off this presentation, we'd like to give a quick introduction of our team.
I'm Evan Braband. I'm the team lead for the Tonee Lift Walker, and I'm studying mechanical engineering.
Hello, my name is Christian Soria Galvaro, and I'm studying electrical and computer engineering.
Hi, my name is Lexi Solsky, and I study mechanical engineering.
Hi, my name is Julia Burling, and I study mechanical engineering.
Hi, my name is Ethan Hufall, and I am studying mechanical engineering.
Hi, my name is Will Reuter. I'm an industrial and civil engineer.
The Tonee Lift is a walker that was specially designed to incorporate a lifting mechanism. The lift can raise items that are on the ground up to a height where they can be easily accessed or reached by the user of the walk. Pictured here is the Tonee Lift model that was developed by our team. The inventor of the Tonee Lift, our mentor Gabby Doyle, created this product in order to assist people with low mobility that are unable or experience difficulty in reaching items on the floor. The model that you are currently viewing on your screen, developed by our team, is the third version of the Tonee Lift. The first one was a prototype developed by Gabby Doyle. The second prototype was created last year by a different senior design team. Shown here is the current version of the Tonee Lift Walker, lifting a brick that weighs 30 pounds. The first Tonee Lift prototype that was developed by Gabby Doyle is shown in the first picture on the left. For this first model, the lift mechanism was built onto a general walker frame that was purchased commercially. The second image shows the second version that was developed by the senior design team last year. And then finally, the third image displays our current model. This video shows the very first prototype being used. As you can see, it is able to lift that item all the way up to the waist of the user. This model was powered by a drill motor, and it was controlled its forward and back down motion using the buttons that already existed on the motor. A main problem that was observed with this design was an incredible amount of shaking when it was trying to lift something heavy. The second problem experienced was the lift plate would lean that could cause items to fall off of it. Pictured here is the second version of the Tonee Lift. This model was never operational, unfortunately, due to multiple issues with 3D printed parts, as well as several motor components that were not able to power the lift under any weight. For the third Tonee Lift design, the team was to create a market-ready Tonee Lift design to incorporate a sweeper arm that would allow users to move items onto the tray, to ensure that the walker that we created was able to be repaired, and to design a Tonee Lift that was able to withstand extensive daily use. This is the system flowdown for the Tonee Lift walker. The system was broken down into the frame, lift, electronics, and power subassemblies. This is the first iteration of the Tonee Lift, and this is a video showing how it operated. As can see in the video, the lessons that were learned from this first design iteration is first, that a gearbox was needed to decrease the speed of the lift. Second, we knew we needed to increase the thickness of the lift plate in order to prevent that bouncing motion. Third, the drill chuck and belt wheel had been glued together, and we knew that we needed to have them be one piece or welded together. Next, we knew we needed to switch out or find a new way to determine when the lift was at its minimum and maximum positions because those sensors were. Finally, we added a requirement to our design that the lifting plate needed to be able to maintain its position at its maximum weight when there is no user input from the control panel. This would ensure that if the user stopped pressing the up or down button, the plate wouldn't just suddenly drop to the ground. In order to incorporate these changes, in the second design, we added a second pulley and belt that would increase the power and the plate stability. We developed a new intermediary component that attached the plate to the actual belt. And then finally, we switched the rail components to be made out of steel instead of aluminum. The final changes made for the last design was that we changed the drill motor from a drill motor to a worm gear motor. The second major change was we had a new method for mounting the motor, and we used a welded plate to do this. And lastly, we shortened the height of the walker frame in order to it to fit with the standard walker heights that are currently markedly available. Shown here is our final lift prototype, and as you can see, it has very smooth process, both up and down, and this brick that is on the plate weighs almost over 30 pounds. This is our design day poster for reference. And we would like to thank Gabby Doyle, our sponsor, Steve Larimore, our mentor, and the University of Arizona. Thank you from the entire Tonee Lift team.